This is my 3D printed conveyor belt. It is a small part of a super big project I'm working on. And actually the original plan was to go online and buy one of these things, but they run for $600 to $1,000. And I was like, yeah, that's a dub. I'm gonna make it myself. And I'm also trying to make this for under $100. That includes all the 3D printing I'm gonna do, all the electrical components, everything under $100. I'm gonna see if I can do it. No promises, but let's get started. If you happen to not know what a conveyor belt is, what it does, how it works, don't worry about it. I shall explain it for you. So conveyor belts simply conveys things. It moves objects from point A to point B. It has two rollers, a belt, and a motor. It takes that rotational motion from the motor and translates that into linear motion. The first step into making the conveyor belt is picking a motor. So I picked up this $15 motor off of Amazon. We need to control the direction of the motor, so it needs to go forward and backward, and also I want to control the speed. And we can achieve that using the H-bridge. So these you could get for about $10 for a pack of 4. So let's say $2.50 if we're gonna use one. Yeah, let's say $2.50. So we have this. The brains of the entire operation is gonna be an Arduino. In the final product, I'm gonna use an Arduino Nano, not the Mega. These are expensive. These smaller ones are pretty cheap. These you can find a pack of 3 for like $15. So do the math. It's probably gonna be up somewhere on the screen, and you know how much everything costs. But let's put it together. So this is the circuit. I was able to get everything put together pretty quickly, but I'm gonna explain how everything works. So the Arduino controls everything. It takes all the inputs and outputs. We have one switch right here. The switch controls the direction of the motor, whether we're going forward or reverse. We have a potentiometer right here, which controls the speed of the motor. We have the H-bridge that takes all the information from these two inputs and translates that to the motor, and everything is getting powered by a 12-volt power supply. As you guys can see, the electrical is kind of all over the place. If it's one thing I learned about any electrical work, is to do it early and to do it clean, especially me, because I have a tendency of blowing things up. So we're gonna print out a control box, get the Nano, do some soldering, and then we're gonna go forward for the next step. Now that we have the motor ready and the control box ready, it's time to go and design everything in CAD. But quick price check, I think everything should be around or under $50, but I'm gonna have the actual number right here. This is what I'm thinking for the design of the conveyor belt. Very straightforward. We have our two rollers, we have two side panels to guide the belt, we have our 4 supports to kind of hold everything together. And one of those supports, our motor will be in there, and that'll be driving one of our rollers. A super small but also very important feature that we have here is the tensioning system. I almost forgot it, and if I would have printed everything without it, I would have been pissed. So what the tensioning system does, it just makes it an easy way for us to put on the belt and then to tighten the belt up to kind of elongate it, so we don't have to worry about it being floppy and moving around too much. So we're gonna print out everything, see if it works. If not, we change something here, we change something there, and we'll end up being good. Alright, so everything is working as intended. The only problem I see right now is it's a little wobbly, and that's just because I forgot to add support in between both of the side supports. So we're going to print those out, install them, and then we're going to try again. Okay, so a couple of changes we made with this second iteration to the build. First, we added supports. It made the overall conveyor belt a lot more sturdy. Also, we took away those two front supports that were each separate pieces, and instead we just elongated those side supports. So what that does is it makes a less amount of pieces, so we have a lot less complexity in the build, and it also just makes the overall build a lot more sturdy. Okay, so the last thing that we have to do is add the actual belt. We're gonna do that, and then I'm gonna add up the total cost for the build. So overall pricing summary, we have the motor, which is $15, the H bridge, which was $3, the Arduino was $6. All of our prints, including all the times we messed up and all the redesigns, we printed 1,000 grams of filament, which is basically one roll of filament I went through to do this, which was $24. The actual belt, we spent $16, and all the miscellaneous extra stuff like the screws, the potentiometer, the switch, the wires, all that extra stuff was a total of $10. So as you can see, we was a decent bit under our goal of 100. The total cost was $74 for this build. So we basically saved $600 to $900 making it ourselves. Alright, so the build is finally finished. I have an idea on how we could test this, so here it goes. So that is it for this build. If you liked it, be sure to give the video a like. And if you want to see how I made an Iron Man missile launcher, click here.